Okay, Mark and I are back. The Pi has finished installing all these library dependencies. And let's go back to our instructions. Um, I don't know, Mark, you're on the version 2 of the Pi Zero, which we know is faster. Did yours take less than 15 to 20 minutes?
Well, it seemed a bit quicker than yours, but must be honest, I got sidetracked reading some Twitter posts and came back to it, and it was done.
Okay,
So,
even better.
well, no official result, but yeah,
Okay. All right.
we could
So
we could do a straight compare. We could try something like that when we do the next one, the Z bar.
yeah, okay, we can synchronize our clicks. Although, yeah, well, I think this one is quicker. Um, so ZBar is quote an open source software suite for reading barcodes. So basically, ZBar is it it reads the QR codes for us and returns them as data. Um, so I'm going to copy the first command to download the binary. So go back here, paste that in. And again, we need this internet connection to be able to retrieve this code or this executable. It's pretty small. Now that it's on board, we're going to call apt install. And actually, I think this will be too fast to be worth trying to do a head-to-head comparison. So I'm just going to go ahead and punch it.
Mhm.
Okay.
Okay, I'm done.
Yeah, I'm still going. Yeah, I guess it was a good test. I'm still waiting.
Did you only know that afterwards? Yeah, I guess the whole build, download and build of the primary dependencies, that would have been the ultimate test.
All right, now that it's installed, we can delete what we just downloaded to keep a nice tidy Raspberry Pi. All right, now the C library for the Broadcom chip. This quote provides functions for reading digital inputs and setting digital outputs using SPI, I2C, and for accessing the system timers. So this is just that we can talk to peripherals like the display hat, I'm guessing. And so there's a series of individual steps. So first we need to download the library as a compressed tarball,
Mm-hmm.
1 whole megabyte. Then we're going to, is this missing a dash? Shouldn't it be dash ZXVF? Or is it just, oh, I guess it worked.
It worked.
Okay. All right, and so what that did was it decompressed it, and we've got a BCM directory, so we're going to CD change the directory into it. And
What is
then,
that BCM? That was interesting because that came up actually when I was trying to connect on my Windows machine. That popped up as a device that was trying to connect. Wow.
um, and so we're actually going to compile the BCM library. So this would be a better test of the 1.3 versus the version 2. So
Mm-hmm.
first we're
Which
gonna,
line? That sudo configure.
yeah, well, the config is going to, I believe, check what kind of compiler features the board supports. So we do that, and it's going to run a series of tests, checking whether the C compiler works. That's a great test.
Yes, it does, but without Doxygen. Warning, Doxygen continuing not found, right? We're continuing without Doxygen.
All right, so now this sudo make and sudo make check and sudo make install. So basically, we're going to compile it. We're going to make sure that the compilation was passes all of its own tests, and then we're going to install it into our system all in one command. And this should definitely go faster on your device. So I'm going to
Go.
start.
And I'll tell you, I'm done.
Wow. I'm still going. Test pass, and now it's done. Okay, now it's been installed. All right, so I cd dot dot, which means backup a directory. So I'm going to get out of this BCM directory, and I can remove the tarball that we downloaded. We don't need it anymore. And I'm going to remove this entire BCM directory that was unpacked from the tarball, because we can clean up after ourselves. We don't need it anymore. The compiled binary was installed into our system. Okay, so that's all the stuff that I barely understand, the library dependencies and all that. Now we're getting into the Python world, which is my comfort zone.
So that's the Broadcom chip, that BCM2835, and that's why my Windows Device Manager picked that up. Interesting.
That's how the device identifies itself.
Yeah, it showed up as, because I was initially struggling quite a lot with trying to get the USB tethering to work, and that BCM2835 popped up in Device Manager without a driver and a whole bunch of things, and I was hoping that that would solve my particular problem, but yeah. Well, USB tethering on Windows 10 and 11 is going to be a totally different video.
I wonder, it probably wouldn't be any easier to run it in the WSL, the Windows Subsystem for Linux.
I actually tried that, and that the WSL2 has got some issues connecting with USB drives, and yeah, that was working for a while. Then it got broken, and now, on my machine at least, it's broken again. So I was certainly, when I work that out, I want to get it working on WSL2, because that is a really impressive feature of Windows 10 and 11, to be able to do a lightweight, super easy install of Ubuntu.
Yeah. Or you could just get a Mac, which is natively Linux, and life is easier.
Yep. Could do that. I did have one for a number of years, and it was actually a lot of my Excel work that I was doing full time that took me back to Windows, because the Excel version in Windows was much more familiar to me, and at the time, this was back in 2012, was just a fundamentally better version. And it allowed macros, which the Mac version didn't allow.
Huh. Because it's like running Visual Basic under the hood.
And that was a really important part of my work, so I had to do that. But I got to tell you, the back in 2010, 2012, the fanfare that the Apple Mac computer used to get at my clients who were all running Windows machines, kind of going, the guy with the white computer is here, looks so fancy. And boot it up and say, yeah, but I'm selling Windows software, Windows-based software, so we'll be opening up this beautiful Mac machine with its beautiful design, and then we're going to be running Windows inside of it in a VM.
Ugliness.
Really fun. Well, software got sold.
All right, let's move on. So, Python virtual env. I kind of assume that if you're building this manually, it's for the purpose of doing development. So I don't bother to explain what virtual env is. Anyone who's proficient with Python should already be familiar with it. But it's just the best way to keep yourself sane when you're installing Python dependencies. So it just creates like isolated directories, sort of, so that the Python packages that you install for one project don't have any effect on other projects. Like let's say you're using some Python package that has to be at version 2 or less because there's some breaking change that you can't support, but your other project needs some package that's at version 7, you know? And so how can you have both running on your same machine? You can't. But with virtual environments, you just create a separate virtual env and everyone stays in their own little isolated universe and life is good.
So sandboxing in essence.
Yeah, yeah. And then virtual env wrapper is just a utility to make working with virtual envs a bit easier. All right. And just like apt, pip is smart and it knows all the things that virtual env wrapper depends on, like virtual env itself. And so it'll pick up those child dependencies automatically. This is taking a while.
And pt2 was one of the apps that we installed further up, if I recall.
Right. Python 3-pip was one of the apt installs. So yeah, we're getting virtual env wrapper, which is what we asked for, but we're also getting the virtual env dependency. Okay, so while that does its thing, we're going to edit our bash profile to add some extra information so that virtual env wrapper can do its thing. So I'm going to copy this and get ready to edit my tilde.profile. So tilde/ is your logged in user's home. .profile affects your bash prompt, your shell environment. There's a lot of other dependencies coming in to support virtual envs. Zip, whatever that does. Yeah, stevedore, file lock, distlib. All right, so those are all on board now. So now I can edit with nano my .profile.
Can I pause you there for a moment?
Yes.
So I've got FG. Yes, this is FG. What's FG? Oh, okay. I accidentally got myself in the nano and then out of it, but not terribly well. So FG got me back in somehow.
FG, I don't know what that is.
Somehow I got out of that nano. I'm not sure what button I pressed. I hit escape actually while I was doing the pasting. And that got me out of nano. And then I tried to open it again and said, okay, you're already editing. Do you want to do that again? And typing FG got me back in. If you follow the instructions, hopefully it shall work.
All right, so I'm at the end of my .profile. I'm going to paste in that info. And so just really quickly, what does this do? It's just setting the work on home directory. And I can't remember what that's used for. It's pointing to /.env. So I guess that's where it's going to put our virtual environment. We're going to specify which Python executable we want to use. We're going to use the Python 3 executable here. And then when we sign in, it's going to run this virtual env wrapper script, which just creates some extra utilities on the command line for us. So Control X to exit, yes, Y to save, and enter. All right, so now we've updated our .profile. So we're going to source it, which means run that profile script to apply everything that's in there to our current session. And the first time you run it, you'll see that it does some work for virtual env wrapper. So it's just creating and depositing some scripts in your this .envs directory. And then we're going to use one of those scripts that it just installed to make a virtual env. This isn't necessary.
Making a virtual environment, yeah.
Yeah. Just to be sure.
SeedSigner -env.
Yeah, and just to be sure, we're going to say, hey, make sure you're using Python 3.
Mm-hmm.
And it's going to be called SeedSigner-env. We do that.
Okay.
And then when it's done, it takes longer on my
Creating
device.
virtual environment. So this is using CPython 373 and seed packages, pip setup tools.
Yeah, so basically it's copying anything that Python would need to be able to have this isolated, protected environment to run in.
And I see the destination is this home py. It's the home py.envs environments slash seedsigner-env.
Yeah.
Got it.
Yeah. I'm still working on things over here. There we go. Now we're done. And so now your command prompt is prepended with this SeedSigner-env to let you know that that environment is active now. So if I were to say, which Python executable am I running from? I'm running from the Python within my SeedSigner environment. And so it maps Python, Python 3, it doesn't matter. They're all pointing to the same thing. So if I do a Python -- version, I know I'm running Python 3.73. Which Python is it? It's the one from my SeedSigner environment. So now any operations, like any pip installs I do, will be within my SeedSigner environment.
Dot profile to quick activate when you SSH in once again dot nano and add to the got it. Dot nano.
Yeah, so we can
Yeah,
go
now
back.
that the environment exists, now that we can.
Right, so we can go back
That's where we
in
want to go.
and edit our dot profile. All right, and at the end we can say work on the SeedSigner-env. So that's going to make it so that every time we SSH into the device, it's going to automatically activate the SeedSigner virtual environment. Control X and Y to save that. So I'm going to Control D to exit my SSH session now. So now I'm back at my laptop. And if I SSH back into the device, and it's the new password, which is very hard to type. Okay, there we go. And so it's going to run my dot profile, which includes activating the SeedSigner environment. So now you can already see my prompt already has SeedSigner-env appended to it. So if I just do a deactivate from the command line, that gets me out of the SeedSigner environment and just back to a non-virtual env prompt. And then if I work on SeedSigner-env, then it reactivates the SeedSigner environment. But for our purposes, we just always want it active. And so you just add it to the profile so that every time you SSH in, you don't even have to remember to set it. You're just in the SeedSigner virtual env.
Fantastic. Okay, I've done the SSH, I've closed and re-entered, and I'm back in that environment. Excellent.
Okay, so that's the optional. If you're going to be testing new code, you'll find yourself often needing to kill the SeedSigner code that automatically runs at startup. We haven't done that yet. I don't know why I put this here. This should be copy and pasted, cut and pasted further below. That's
So put it in the profile file?
Sure, we can do that. It doesn't hurt. It doesn't help us right now, but profile. And we can even write a little note to ourselves, like show the process ID PID of the SeedSigner process. Auto runs on startup, so we can kill it. Okay. So now if I apply my profile, it's going to tell me it didn't find anything for called main.py that's currently running.
Mm-hmm.
Takes a while. There we go. Or well, it just returns, yeah, grep. Okay. Anyway, now we get to the good part, downloading the SeedSigner code. So we're going to use git to clone the SeedSigner repo by telling it the URL of the SeedSigner repo. So git clone the URL. And by the way, if you pwd, that shows you your current directory. And so everything we've done has been in the py home. So if you do tilde or cd tilde slash, that is your home slash or slash home slash py. So
What's the command to see your current directory?
pwd.
pwd.
I think cwd also.
Yep.
Yeah, I think, is it some Linux or cwd?
pwd works. I'm in home py.
Yeah.
So I'm actually in home py within the SeedSigner environment. That's not actually the same as home py outside the SeedSigner environment, or
They're to use one of my favorite words, they're orthogonal. So pwd
what is that?
pwd tells you where your terminal is currently located within the file system. So, you know, like if I cd dash dash, I've backed up and now I'm only in home.
Yeah.
But if I cd into py, okay, now I'm in the home slash py directory. That's completely separate from which virtual environment is running, if any. And because the virtual environment, all it's really doing is it's just mapping which Python to use. So if I deactivate my virtual environment, and anything that activates or deactivates takes a couple moments on the Pi0. So now that it's deactivated, if I ask which Python executable am I going to run, it's a different one, user bin Python. And on some, sorry?
Understood.
Okay. And then on some, this is perfect. So in the normal terminal session without the virtual environment, not only is it a different binary pointing to a different binary, it's a totally different version of Python. It's 2.7.
Yep.
So
file system on the one hand, and kind of binary code environment applications that we're calling independent to each other. And hence your phrase orthogonal.
Yeah, exactly.
Got it.
I'm just showing off my vocabulary. All right, so from slash home slash py, and again, I'm going to pwd, make sure I'm in the right place. Now I'm going to git clone the SeedSigner repo. Okay, and we're going to grab the whole repo from GitHub. And then once it's down, the next step I'm going to do, well, I'll show you. All right, almost done. So when it's done, if I do an ls, I can see that it's created a SeedSigner directory. I'm going to cd into that. And now I see a bunch of files. And if we look at the SeedSigner repository, let me do that in a new window. We can look at what's in the root of the repository. License.md, readme.md, pytest, requirements, SeedSigner pub key, setup, and hey, it's all the exact same files because we just cloned the total SeedSigner repo, a copy of it, into our Raspberry Pi. So now that we have a copy of the entire repo, we need to check out a specific branch. So this probably should be updated. If we look at, let me bring back that if we look at the SeedSigner repo, the currently active default branch is called dev. If you click down, there's all these other branches, including main. So in the past, main was the default branch, but we've changed our workflow so that dev is the default branch, and then when we do a release, we merge the release from dev into main. And then in addition to these branches, we have release tags, which shockingly corresponds with all the releases we've done. So the most recent release was 0.5.1. So at the command line here, and again, this documentation is focused on developers who might be making changes to the code. But as a starting point, we should really do a git checkout. And checkout just means switch to this branch or switch to this tag, 0.5.1, 0.5.1. Okay. And so it says I'm checking out 0.5.1. Head is now at some hash. And actually, let's, this is a little super nerdy, but head is now at this hash, 2BA. If we look at the SeedSigner history, and we can look at, let's see, is this all of our commits? Yeah, all of our commits. We can go back through the history and we can look for this 2BA, not on this page, older, not on this page. Wow, how old was... Oh, this is only March. It's probably not the most optimal way to do this. Basically, I'm trying to look for... See, all these commits have their own like little commit hash. And so by checking out... Oh my god, where is this commit? No. Actually, you know, I should be in the main branch. Main. There it is. Sorry. So that commit was the one that took the changes in dev and merged it into main in order to do this 0.5.1 release. And so Git is saying you are now equal to this commit hash, 2BA. And that matches this. So if we look at the main branch, we can confirm, okay, we are at the most recent release, because by convention, we only commit to main when we're doing a release merge. And so we can just confirm, like, yes, we are completely up to date with the main branch. So really, we could have just done git checkout main, and git status. There's probably, I don't know, there's some git command to find the most recent release or the most recent commit hash. But either way, you know, for most people, they're going to want to be, you know, connected to a specific release number. Like, so git checkout 0.5. If I do 0.5.0, okay, now I've gone further back in time.
Yes. So if you looked at the branch 0.5.1, will that have the same hash as main does?
That is a good question. Well, yes, because it's a tag.
Ah, right.
Yeah, it's a little confusing because there's like there's
because it was the merge into main, and so there is no 0.5.1 branch. Main is it.
Right. Yeah, there was never a branch called 0.5.1. So if we look at the releases, this most recent release is associated with a tag. That's this little icon, tag 0.5.1, and its associated commit here is 2BA. So that's kind of like both ways we're getting at this.
Excellent.
So we could even do, let's see if I'm right. Git check out that commit hash. Yeah, so there we go. So now we're at that commit. So there's multiple ways to get to the most recent release.
Nice.
But the tags are the best way to go, because you can just go in here and just say, okay, show me all the tags. What's the most recent tag? The tag with the biggest number. It's 0.5.1. And then if we ever have a release that isn't fully like ready to go, like the 0.5.0 release was so big, we wanted people to start testing it before it was fully finalized. So we did this pre-1, pre-2, pre-3, release candidate 1, and then the actual 0.5.0 release. So we will always be clear if it's a main release or if it's like a kind of a test, pre or release candidate.
I remember that. That was just before 2022 conference.
Right. Because, we wanted to get the 0.5.0 officially out just before the conference, but we're like, this is dumb. We're like racing, and if we miss something, like, let's just do it as a release candidate. And yeah, like, it's not like it'll be much of a difference in the publicity bump. All right, Zoom is telling me, let's see, we're down to our last 7 minutes, but we're making good progress here. So let's continue. So we've checked out our 0.5.1 branch. We can get back to other details about later in future live streams. As you get deeper into making code changes, we can talk more about testing a specific pull request and things like that.
Great.
But there are still setups. So we did the apt install libraries into the Linux operating system. Now within our Python virtual env, we have Python dependencies that our Python code relies on. So these are other Python libraries that are that we're building off of. So we need to install those as well. So we can just do...
So like we did a pip3 for the virtual environment wrapper, we're now doing a pip3 itself of its requirements, okay?
Well, of our requirements. So if we look at the repo, requirements.txt has a bunch of different Python projects that we point to. We're asking for very specific versions of each of these. And in many cases, we had to customize them. And so it's our own SeedSigner fork of like this PISBAR or the SeedSigner fork of mbit.
Of mbit.
Right. And then like in this case, this UR types library from jresun, which is for the Crux project, we're pointing to the original library, but he just hasn't made a release that can be installed through pip in the normal way. So we have to do it through this git notation. So that's what this is. Oh, here's that jresun library going by.
And because we cloned the GitHub we have, that's how the Pi has got that requirements of TXT file. Right.
Exactly. Yeah, we cloned our repository, and requirements.txt is one of the files at the root of the repository.
Right.
And so anyone out there who is listening and wants to get a commit into an open source project, our last update of the requirements.txt was to point to our fork of mbit, and so that we could include the compiled secp256k1 binary for the Pi0 to speed up the Bitcoin calculations. Stepan Snigarev has now accepted my PR to merge this binary into the main mbit library. So we no longer need to point to our fork of mbit. We can just point to mbit 0.5, and we will get what we need. And so somebody could literally just change this one requirements file and specify so basically remove all of this and just say equals 0.5, and that would be a valuable pull release that we would merge into our repo.
Okay, that's pretty straightforward.
And you do a commit into a open source project in the Bitcoin world, and you get free tickets to the Bitcoin 2023 conference. So pretty good deal. This is valuable intel we're dishing on our SeedSigner live stream.
Absolutely.
We've got 3.5 minutes on Zoom. I can just restart it if we run out. So, okay.
So your recompile of mbit was, if I recall, because the processor type, you made a compilation specifically for the Pi 0 processor type, and then got it to run that much faster.
Exactly, yeah. So here, let's see. We can look at the SeedSigner repos and our fork of mbit. In its source directory in util, there are pre-built binaries for different operating systems for SecP 256K1. And there wasn't an ARM v6L precompiled binary previously. So if you look at the dates, like Stepan launched mbit with support for all sorts of environments, but he did not do the Pi 0, which is ARM v6L. So I figured out how to compile it for the Pi 0. And so this is just a binary that's dropped into the library. And then Stepan has some cool code to figure out if you are running the binary or if you're running the pure Python implementation. Yeah. So his fallback here, if you don't have a binary, you run the pure Python implementation of it, but then doing that math in Python is slow.
Got it.
Yeah.
And now we don't fall back into that environment.
Right. And we got like an 8.5x speed increase in generating Bitcoin addresses by using the binary. Zoom is about to kill us, so I'm going to exit and then...
so I read up on that, if you do a leave meeting,
okay,
and then you rejoin, that's apparently the quickest way to do it. And
okay. I only have end. So you may have to hop back. I'm going to end. Oh, I can leave. Okay, you're the new host. And then I'm going to join. I don't even know how to join my own meeting now. Oh, I'm back. Hey, can you hear me? Oh, wait, I'm muted. All right, can you hear me?
There you go. Yep, I can mute you, and then unmute. There you go. Now, I think I'll just make you the host. Exactly how to do that. Here we go, and keep the host.
Wow, that was beautiful. And we have 40 minutes, huh? Nice job.
Right, and you're the host again.
Right. Okay, so okay, so the next thing is this note about PISBAR. So there's nothing to do on this PISBAR note. It's just here to explain what we're doing. So if we look at the requirements, and maybe this has changed. Let's see. Let's go back to the SeedSigner repo, and let's look at our requirements.txt. So PISBAR, is not in here at all. Okay, maybe I do have to read something here. I'm confused. Why is PISBAR not in our requirements? Am I blind? Oh, here it is. Okay, I am blind. Okay, so this is just explaining, um, and then we can edit this. So it's explaining that we're not installing the normal Pizbar, we're installing the SeedSigner fork of Pizbar. pi_zbar is probably the right way to say it. And this was required in order to support the compact seed QR scanning format. If we did not have an updated version of pi_zbar, that zbar library couldn't read the binary format of the compact seed QRs. And it turned out that we only needed like two small changes to pi_zbar in order to enable it. And so I've discussed each one here. And the nice thing is somebody had already fixed each of these two items that would enable it to read binary QR codes. But the repo has been abandoned. So even though the fix is there, there's nobody maintaining it anymore to merge the change. And so it's life in the open source world. The only thing that we can do is fork the project, merge the changes in that we need it to do, and then when we install, we say point to our own fork of pi_zbar. And so this is all just an explanatory note. There's nothing to do, but it's just to explain the weirdness of, because this was the first forked repo that we included in our requirements in this way. So that if anybody savvy did look and say like, hey, wait a minute, why are you running your own fork of this thing? What have you changed? This is just our documentation for what we had to change. And thankfully, it was pretty easy to fix it. And then this information is out of date because we said originally we were pointing to my custom fork of pi_zbar, but I've since handed over control of that repo to SeedSigner, so it's now a SeedSigner controlled repo because just for the good of the project, you don't want, like, you should feel okay about this given that it's within the SeedSigner umbrella within GitHub. But if this originally said KD Mukai pi_zbar, which is, people know who I am, but it's just a tiny bit sketchy to have like one of my personal forked libraries as part of the source code. There's no reason for that to be. So now it's the SeedSigner owned and controlled fork of pi_zbar. I don't even think I even have access, like edit access to that fork of pi_zbar that is now under SeedSigner's control. I can't remember now. But anyway, so it's just a way to hand things over and do things more cleanly. Okay, let me make sure. Mark, are you still there? Uh-oh, Mark might not be there. Let's see. Maybe he did get kicked out. There we go. Okay, sorry. I guess you got kicked out.
I did.
Okay. Well,
Our
sorry.
fix didn't work.
Anyway, you're back. I was talking to myself to a little bit, but hey, we got a YouTube comment from Jan. Congrats for getting sec P256K1 to compile on the Raspberry Pi Zero. Thank you. That was
Yay.
if I could go back in time and tell myself like 5 or 10 years ago, like, hey, you're going to be learning how to compile C and C++ code from Bitcoin Core on a $5 Raspberry Pi computer. I would have been like, what? I don't know how to do any of that.
It's exactly what I was going to tell you, that from English teacher to compiling processor-specific math libraries, yeah, that's a nice jump.
Yeah, and I mean, it was actually once I understood everything, it was easy. And all credit to Stepan Snigarev, who had the process down to compile for all those other targets. So I think I can't remember now. I don't even know if I had to change anything. I'm getting confused because I've been doing so much work in MicroPython now that I can't remember what changes I had to make for MicroPython versus just this SecP library. But anyway, yeah, I was super excited.
Nice flex. That's pretty cool.
Yeah. Okay. Anyway, let's keep moving. So,
did I miss anything while I was off the Zoom?
no, just my explanation of.
We were just talking about the PYZ bar.
Yeah. Yeah.
Yeah, I went and had a quick look at that. That Katie Mackay, your repo that's actually now redirecting to SeedSigner.
Right. That's what I was talking about. That once I got everything working, I handed over control of my fork of PyZbar, just because for security, for cleanliness, our project shouldn't be pointing to like a repo that I control. Because in theory, if I want to do something evil, or if I'm compromised, we shouldn't have any dependencies on something that I control. Like I don't even have any privileges in the SeedSigner main repo. Like I can't merge code.
Oh wow.
Yeah, and it's just because you want separation of concerns. Like I'm the most active developer, but if I could just merge my own code, I could just release whatever version I want with no oversight, and that's not a good practice.
Absolutely.
Okay, so now we're going to configure systemd to run SeedSigner at boot, and so systemd is just a scheduler. It just makes sure that these services run when it starts up. It will also restart any service if it crashes. And so we're going to edit a configuration file to establish the SeedSigner service. So I'm going to copy that, and we'll go to edit. All right, and so it's a blank file because there is no service created yet. And we can just wholesale copy the contents that are listed here and just paste it in. Control X, yes. Okay. And we can quickly look through it. User is the Pi user that we've been using throughout. Working directory is just where we're starting from, starting from the source directory within the SeedSigner project. And then what we're executing is we want to run the Python executable within our SeedSigner environment. We're going to run the main.py, which kicks off our entire SeedSigner code base. And then we're going to pipe any output. So I have a lot of print statements, debugging statements in the code. And, well, I think I've gotten rid of most of them. But for the production release, we wouldn't want, like, let's say I have a print statement to print, an XPub as part of debugging. And let's say I forgot that I left that in there. We wouldn't want our code to be logging that output, those print statements anywhere. We want to make sure that those print statements, well, first, we don't want them in the code in a production release, but if we forget any, we don't want them stored anywhere on the device. Because normally you log everything that runs, on your Linux OS somewhere. But so we are explicitly saying, put any output to dev null, which means it gets sent to oblivion. And then this notation just says, do that for standard output and standard error, which are just these two output targets that your code can write to. So basically anything that comes out of our Python code, pipe it into oblivion.
Just goes null and it's gone.
Yeah.
Beautiful.
Restart always. So if our code crashes for any reason, just restart the process. This is how the reboot, the quote reboot works in the SeedSigner UI. It kills the process and then it relies on system D to automatically restart it.
Oh, right. Okay. That's great. Because it's actually system D that is the host. Yeah, it is the host environment, which is then running the SeedSigner code. And obviously, the not that I think it's particularly long, but the boot up time, etc., is happening. Then the SeedSigner code starts when this service comes alive, and it says, right, start this job.
Right.
Got it.
And then in the SeedSigner UI, if you select restart, I forget what, I think we use the words restart or reboot. If you select that option, it kills your Python session, but it doesn't reboot the entire Pi because that would take another 45 seconds. So it just kills the executable, and then system D restarts it, and so you can resume much more quickly.
Excellent.
And then there is a note for local dev. You don't want restart always. You want to be able to stop
we want
it.
to see the messages, and we want to see the what happened just before the crash.
Exactly. So when I'm in local dev, I not only do I say restart no, but as we'll see in this step, I disable the SeedSigner service entirely because I just don't want it to run. Because I'm going to manually start the SeedSigner code, and I'm going to manually stop
by
it.
running main.py.
Right, exactly. So, but for now, let's go ahead and enable the service that we just defined. Okay, enable, and then let me pop on my little webcam here. All right. So the service is running. Let's see if there's more.
So I got a created symbolic link.
And then reboot. So, all right, so this is going to take 45 seconds. I'm going to do my reboot. And so this is going to reboot the entire board. So we're going to have to wait 45 seconds for it to come back. But I am going to highlight this because if we've done it all right, we should see SeedSigner 0.5.1 auto booting up when the board comes back.
Oh, awesome.
Or we won't if something is wrong.
You get so focused on the topic. Oh, mine's popped up already. Oh, yes.
It worked?
0.5.1.
Awesome.
Yeah. You get so focused on the topic and go, right, what are we doing here? Okay, great. Oh, yes, this little Pi device. Yes, that's what we're trying to configure, not the actual computer that we're staring at.
Yeah, although I'm getting filled with doubts now. This is taking... Oh, yay, there we go. Okay. All right. Let's see. What? How do I load my... yeah, I have a camera profile to correctly expose for the screen here, but it's
for the screen colors.
yeah, it's not applying correctly. Well, anyway, you get the idea. It worked. Yay!
It worked. Code started.
All right, so now let me SSH back in. Oh, air gapped.
So actually, now mine is because my Pi actually is using my Wi-Fi signal. I'm trying to think about that. My Pi is actually using my Wi-Fi signal. So I've actually got my SeedSigner attached to the internet.
So yeah, and that's coming next. Let's see.
But of course, ultimately, it's going to be. I mean, this is a dev memory card, so whatever happens on this memory card is not going to have any impact to me when I put a real seed in.
Right. And further down in the manual config steps is disabling Wi-Fi and Bluetooth. And so because you're using the 2W that has Wi-Fi on board, you would make sure that you would want to run all of these steps to totally knock it down. Although I would not knock out SSH service if you want to be able to SSH in.
Correct. And I actually can't at this point knock out the networking service, or I guess I'm not sure which probably the wireless LAN part, because that's actually how I'm getting into the SSH.
Right.
Interesting.
Right. All right. And then if we look back at the instructions, okay, we successfully see the splash screen. Great. So there are some further commands we can run. So we can remove swap file. So the swap file is, it reserves some of the SD card space for kind of a virtual RAM component. And the worry with SeedSigner is, what if the Python code writes some of your secrets to RAM, but instead of the volatile RAM, what if it's the RAM disk, the virtual disk, the swap file? And so we're going to say, hey, no worries. We're just going to disable a swap file entirely so that it can't do that. Okay, so while that goes, auto remove is just going to prune out any unused libraries that apt knows is now not necessary. Okay, it's still working to remove swap file support. And this is just like extra, paranoia level, but these steps are done on the production releases. The last thing we want is someone to investigate their SD card and being like, oh my God, you guys, it's actually writing to, a file.
It's writing to the disk, yeah.
Yeah, so.
And at the same, the current, is it 5.1 that was the first release where you didn't have to have the SD card actually in it?
No, that we do not have a production release that supports that yet.
Oh. My apologies, I thought it was already there. I hadn't tried it. But also I'm careful not to use my SD card for anything else except that.
Yeah.
But as I think you said in the Telegram chat, the evil maid attack and that vector would be pretty amazing if they were able to do that and clean the house.
I know, right? Exactly. Yeah. I mean, let's see if I can. Again, I got to make sure I don't dock something sensitive on my desk here. But here's my webcam. So here's what the evil maid has to contend with in my house. Okay, so if we look to my left. Where are we? Here we go. Here's an ESP32 chip that's under development for hoping to get SeedSigner support. Here's a SeedSigner. Here's a Pi0W.
Which one?
Here are two RP2040 chips.
Oh my God.
Here's a display screen we're not using. Here's a SeedSigner. Here's a SeedSigner. Yeah. Wow. And then, wait, let's see. Where is it? Let me set this down.
A boot disk that doesn't work.
But yeah, if we dig a little deeper into my messy desk, hang on. Oh, look. Oh. It's a QR code. Oh no. Wait. Oh no, it's another QR code. And
tricky, that one might scan.
Oh, here's a QR code. Yeah, so that's
Fantastic. Yours is security by true obscurity. Which device do I even pick up? Which one do I
right.
stick them,
Oh, you know,
my new SD card
actually,
into?
I
Which
missed
one
it.
does he use?
Look, there's another seed signer hiding there underneath the chopstick wrapper. Okay. So yeah,
Well, that's got your password on it, so that's cool.
right. All right. Anyway, where were
Yes.
we? So,
Right,
oh, the
we're
last,
at local testing.
yeah, the last step. Well, remove the actual swap file from the OS if there was one. All right. So that's done. And then this, I think we should leave for later. Like, so at this point, our seed signer is now should be identical to the production release. Now, when I say identical, I mean configured the same way, running the same code. It's not going to be bit for bit perfect match, simply because of the sudo apt update call. So that's just saying, hey, make yourself aware of any new library updates that are out there. Like, oh, library ABC now has version 7.2.3. And so just by calling this, there's a time like component to it now. Like we are up to date as of July 30th, 2022 after running this call. But, you know, the 0.5.1 release ran this call in
Was 2 months ago.
right. So we've already created changes on our SD card that don't match what's in the release. They're not substantive changes, but and then there, you know, I'm sure there's still like underlying OS level things that we can't control, like you know, just installing a you know, some apt package. There's probably a date stamp on when it was updated or when it was installed. Like, you know, the Pi user installed the zbar library on July 30th, 2022. You know, it's like log files and those sorts of things that are innocuous. But again, they make the data on the SD card very slightly different from the official release. So what that level of identical matching is called a reproducible build. If it's bit for bit identical, you build it on your local machine, you compare it to the release, it's identical down to the last bit. We just can't do that because we're running on top of a Linux OS, and I don't think it's possible to get that level of identical result.
But I guess in the way in which somebody who's doing a manual build, in order that they want to make sure that I've reviewed the code, I've seen what the code actually says, now I'm going to do the build myself, they wouldn't necessarily care what the actual Keith and SeedSigner people have actually built, because that's not going to be the one that they're relying on. But I see your point in getting a reproducible build would prove that there wasn't any manipulation that happened during the build process, which you do or SeedSigner does?
SeedSigner does. So basically, he does all of these exact steps. Like he literally follows the same instructions that we were following. And so if you were SeedSigner, the only thing left to do would be to like there's a way to generate an image off of the SD card that we've created, and then sign the image with his PGP key, and then post those, post the image and the signature, and the SHA, the hash. But yeah, these are all the steps that he follows.
Okay. Right, great.
So yeah, I think that's probably good we've done our manual build. Our code is running. Let me bring back my SeedSigner. Screensaver is doing its thing.
Looks fantastic.
Yeah, and then so just a really quick note. Let me find that grep. There we go. So if I were to run this command while my SeedSigner code is running, I get the. It's a little hard to read the sorting. Let me shrink this so it fits on one line. Too small. There we go. So we don't care about the grep line. That's just saying, hey, you ran grep. Grep is running. But what we do care about is the main.py line that's running. So this is what's actually executing. So this second column.
What command was that?
That is ps aux pipe grep main.py. So it's in, if you just search for grep in the manual instructions, you'll see the command. And so that's just saying, like, if you just do ps aux, it's going to show you every single process running on the Pi right now. But
then we grepped it to just main.py.
Right.
Right.
And so that gives us the process ID. And so now that means I can just kill that process. And oh, again, I've got my picture-in-picture going. So when I kill it, the screensaver just froze because it stopped getting updates. But now systemd just did its thing and automatically restarted it.
Now, I see your point that there's almost, are there two of them running, or is there just one? It comes up on two lines.
It's because
main.py.
Yeah, it's because your grep command includes the search term main.py. So grep is finding itself. Got
it. Okay, and there's the runtime on the other one, which is 328. So if I do on my machine kill 328, it's gone and rebooting.
Yeah. And so for local dev,
wow,
this
is the start is fast, hey?
Yeah, it's just Python code. And then let me see. Let's edit the systemd. All right, so we're going a little rogue here. But just because this is quick, I'm going to go back and edit my systemd definition for SeedSigner. And I'm going to change restart always to, I think it's no, never. No, restart no. All right, save that. And then I think we have to update the service. I don't think it knows that there's a change yet. I don't know if it's update or reread or something. It doesn't know. I might have to do a. Let's see. Okay.
Probably have to do the enable or
it might be reload.
Disable.
Might be reload. Okay, quit that. Let's try reload. It's not applicable. Ugh. Restart. Can try restart. Well, anyway, I'll stop it for now.
Okay. That seemed to work. Unit file drop-ins changed on disk. Daemon reload.
Okay, that was useful. All right, but I got to do that as sudo. Okay.
I'm going to say thanks for showing some of us newbies a little bit of Keith doesn't know the commands, all the commands in his head already. Thank you very much.
No, I mean I literally tweeted like Stack Overflow is down. Guess I'm going to go for a walk. I can't program now. Okay, so systemd is back up. It did boot SeedSigner. I'm going to go back and find the process ID, and it's going to be different every time. I'm going to kill it, but because I said restart no, it's you can't tell, it's not a blank screen, but it's not it shouldn't be responsive. Yeah, so it's ignoring my joystick input now because it's not actually running. It's just dead. So that allows me
Oh, wow.
to go into the SeedSigner code and into the source directory. And remember, I've got my virtual env already active. So when I say Python, I'm running the Python from my virtual env. So I can just say Python main.py.
And actually, that command that was actually running was the process. The process actually showed the command that it was running.
Oh, right, exactly. I could have just, even without the virtual env active, I could have just run this whole command because it's pulling from the correct Python. And we see there is debugging, right? So this is the debugging that we normally eat into oblivion, but now it shows up. So like if we, navigate around, we see this debugging going on.
Oh, okay. I'm seeing that. Right. Oh, wow. Aha.
Yep. And so now I have programmatic control. I'm running SeedSigner manually. I can just Control C to kill it. It just died. It's ended. I can start it up again, and it'll resume in a moment or two. And then on a subsequent live stream, we'll talk about setting up like your local dev environment so that you can test code changes. Because right now, in order to see a change, you would have to edit the Python file on the Raspberry Pi, and I mean you can do it, but it's cumbersome. Like
it's long, it's cumbersome, absolutely.
Yeah, like where is it? Is it controller? There it is, version. What should we call this version?
Let's call it, what's our date today? July 30.
No, it's version bunnies. Okay.
Which file was that?
SeedSigner controller.py. So now when I boot it and take a look at my screen, bunnies!
Gee. Nice.
So yeah. But anyway, it's not really viable to do all of your code editing, from the terminal over SSH. So there are better ways to do it.
So once the in a subsequent live stream we could set up not sure what the right terminology is. I know it as a kind of step by, we can step through the code and pause, break, and do some immediates.
Yeah. Yep.
Fantastic.
All right. Well, let us wrap up.
Well done. Done. Thank you very, very much.
My dog is eager for a walk. She's snoozing right next to me here.
And a very famous dog it is.
Yes. This is Kuma. Actually, let's see.
Kuma was the code name for 050.
Yes. Right? Yes. Kuma, the shadowy supercoder release.
That's it.
Let's see. Always got to worry about doxing stuff around my house here, but there she is. Oh, it's so dark. I gotta change. She's an all black dog, so it's.
Yeah, exactly. I used to have an all black cat, and to get a good photo of them, you need to use that night mode. Otherwise, you just get a dark shape that's moving around.
Yeah, exactly. So yeah, there's my girl. And a little bit of my messy living room.
Normal life, eh? Normal life, not messy.
There's her hamburger.
Beautiful. Right. Well, Keith, this has been really amazing. Thank you so much. I had a fantastic time and really feel kind of, as if, even though, sure, we just did something that was simple for you and followed some steps that really was, for me, it was a nice achievement, a big achievement. So thank you very, very much for that.
Yeah, and thank you for reminding me to do this. I've been wanting to do it for a while, and like I said, I ran into an error that I couldn't solve for like an hour, just with that stupid line break in that one text file. So when I get a chance, I'll update our documentation to note like, hey, make sure there's no line breaks. So it's all good. We're all we keep learning more and making the documentation more bulletproof and prevent other people from running into similar stupid problems.
Absolutely. So, just one quick question I want to ask you. So, if I wanted to do an edit on, say, one of the manual build files, and I choose edit on in GitHub, either edit this file's grayed out. So, to make a change to that, what's the process supposed to be?
So you would.
Because I'm also a bit new to GitHub too.
Yeah, so you would go to code on the homepage of the main page of the repo. It's just like we did. We cloned the repo to the Raspberry Pi. You would do the exact same thing on your local computer, or actually even better than that. You would create a fork of the code. So you would click this fork button up here. And then within your fork, so instead of SeedSigner/SeedSigner, it would look, so like mine is /SeedSigner, right? So this is my fork of the repo. So when I clone it, I'm cloning my fork of the repo to my local machine, and then I'm making changes. I can commit changes to my fork. I've got my own branches that I'm working on. Let's see. Yeah, I mean, I just have a whole bunch of stuff. Like I never delete branches. And so you would make the changes in your fork, and then once you've made a change, you would then make a pull request to propose that you merge your changes into the main repo. And then that starts a review process and testing process where we would look at your code, we would, give you feedback, suggest changes, run it, make sure it makes sense.
Got it. So pretty much so that is the correct way of doing it. So it's fork the code, make the changes, then do the PR, or in some cases do the PR first, just to read the room, so to speak.
You would fork it, you would make the changes, you would commit your changes to your fork. It's the only thing you don't have permission to commit to the main repo. Commit your changes to your fork, and then GitHub makes it pretty easy. As soon as you make a commit, it basically pops up a UI on this page that says like, hey, do you want to, make a pull request back to the main repo, back to the SeedSigner repo? And then when you do that,
and then I'll send some comments along with that.
And it shows you a diff, so you can see like what are the changes that we can all see. So like if we look at the pull request, that
I've seen and done a bunch of that on the README file already. I guess it was a bit confusing to me because I started working on somebody else's pull, on somebody else's fork, and then so my fork goes through theirs, which then ends up in the main repo.
Yeah.
Cool. Okay, beautiful. Right, well, it's doggo walk time, and time for a late lunch for me here.
All right, thank you for doing this. This is it's fun, and
awesome.
We will see how many tens or ones of viewers we have on YouTube over the days and weeks.
Great, thank you.
Okay, see ya.
Cheers.